Today we are going to see correlations, and let us learn what are they. So, a correlation exists between two variables when the value of one are somehow associated with the values of the other in some way. For example, here, we have a graph, and we have many dots here, okay? We have many dots, and each dot represents a measurement. Each dot represents a measurement here. This is stress test score, this is stress test score, and that's blood pressure reading. Stress test score and blood pressure reading, okay? Yes, and you can see that if we try to draw a line here, we can draw a line approximately upwards. And this means that there is a positive relation. If we can draw a line upwards, this means that there is a positive relation. Now here you can see different examples. This is skin cancer mortality versus state latitude correlation. And this is latitude, and this mortality you can see here. So you can see that this somewhat tends to go downwards, okay? This somewhat tends to go downwards here. Like if we draw a line, it tends to go downwards, okay? So we say here there is a negative correlation, by the way. We say that skin cancer, as skin cancer mortality increases, state latitude decreases. Or as state latitude increases, skin cancer mortality increases. So one of them decreases, the other one increases. There is a negative relation. This is the meaning of that. One of them increases, the other one here decreases. Now, these are different measurements that you can find. You can guess what are they here. Now, in this measurement, you can see that there are many dots, but it's not possible to draw a line like this, starting from left going to the right, or it's not possible to draw a line starting from right going to the left. So we cannot draw a line here, right? We cannot draw a line. Therefore, we say the correlation is 0. So these measurements are not related to each other, okay? So this they are just random. So here we can see that somewhat it tends to, if I draw such a line, okay, it's not perfect, but somewhat there is a negative relation. Therefore, we see it's negative. Here, this is 0.5. It somewhat tends to go to upwards, okay? So it's positive. And it's not, they are not very close. Here, the closer that they are, okay, the bigger is the measurement. For example, this is minus 0.7, okay? The closer they are, this is negative, but somewhat more strong than this one. They are more close. And here, yes, they are really close, okay? If you consider this one here, these measurements here, these measurements are more close. So here, this correlation is bigger than this correlation because these measurements are more close to each other. So this is bigger than this one. If you look at one here, over here, you can see that these are even more close to each other, right? Since they are more close to each other here, we say that, okay, these are even more related, and the relation is negative here, okay? Why? Because it starts from this left and goes to right, to the bottom, okay? So this is negative. This way is negative, this way is positive. Yes, we can see some more measurements, and here this is an example that there is non-correlation, and this since they are not very close, we say that there is a low correlation. And here these are really close and they are high correlation. And now since they are very close to each other, we say that they are perfect correlation. Okay, they are really close to each other, so we say that they are perfect correlation. Okay, so and these ones, okay, it goes up, it's positive, it goes down, yes, negative. This is curved and this is partial. Why partial? Is there is a correlation until here, positive, and then okay, it lost. This is there is no correlation over here. Some more shapes. So today we are trying to understand whether some measurements are related to each other and this relation is positive or negative, okay, and whether this relation is strong or weak from the figures, okay. Therefore, I am showing you several figures here. Now here you can see that they tends to go upwards, and when it is like that, we say that it's strong positive. Okay, and here, okay, they are even more strong. You can see that they are almost aligned, okay, but it's negative. Upwards, positive. Downwards, this is negative. We can say that this is moderate, this is moderate. And you can see here that, yes, weak. They are weak because they are not close to each other. They are weak. The relation is weak here. And here you can see that they are also, it's weak because they are not close to each other. Okay, and this tends to go downwards. It's negative, weak, negative. Do you understand the difference of these shapes? Okay, and this is there is no correlation between these measurements because they are distributed. Okay. Yes, now some more measurements. Now this is wind speed and RSV cases. We can see here that wind speed is negatively correlated with RSV cases here. Okay, why? Because from these points we can draw a line like this, but the correlation is not strong because these points are apart from each other. They are not very close. And here, yeah, it's positive. It somewhat goes upwards. Okay, it's not like this, but this is also acceptable. It's somewhat positive. Okay, but it's not strong here. Again, this is somewhat positive but not strong, and these are called outliers, outside of, very far away from the other measurements. Okay, these are outliers. These are extreme cases. Okay, so here this is a curved wind and temperature. You can see that this is a curved correlation. Yes, now here you can see that some other correlations, okay, you cannot guess, of course, what is the exact point here. The highest number that you can have in a perfect correlation or a very strong correlation is 1, okay. The lowest number that you can have is -1. You cannot have numbers like 200 or 1000 as correlation. It's not possible. It's a number between -1 and 1. Okay, correlation coefficient is between -1 and 1. So why are we studying this? Because you are seeing this kind of graphics or if you didn't see until now, you will see them on articles, on books, and on different advertisements maybe, or on a scientific paper. Okay, so and they don't explain you generally what is its meaning. Okay, this is the graph they give, so you have to know what is its meaning here. Okay, so if you see such a graph, it means that it's a positive relation. Okay, it's a positive relation. It goes upwards, and this goes somewhat downwards, and this is very, very distributed. Okay, so it's really, the closer that the dots are, the stronger is the relation of this x-axis and the y-axis values. Again, This is 0. This is nearly 0. You can see that's minus 0.3, and this goes upwards 0.5. Okay, it tends to go upwards, tends to go downwards, tends to go upwards, and almost perfect. But negative because it goes downwards. Some more. Yes, CT, MPG, and weights. Okay, this goes downwards, minus 91. Goes upwards, you can see, and distributed, but tends to go downwards. Here, minus 0.08, so it's almost minus 0.1. Okay, it's really really weak. This is really strong. There, you can see it from the shape, and it's positive, and this is. You can see that there is no relation here. Yes, so to sum this, we can say that the perfect negative or the strongest negative relationship possible is -1. Okay, the highest number for this is -1, and the highest number for positive relationship is +1. And here you can see that this is 0.9. Okay, they are almost close to each other. And this is weaker, and this is yes. Yes.
In the previous slide, the fourth one, the minus 0.8. Why you can't say like there's no correlation?
Because it's minus 0.08.
No, I mean like from the shape, how I can tell like if it's negative or if there's no.
In fact, it's not really obvious here. Okay, it's not. You are right. It's not really obvious here. And statistical tests gives us these results. Okay, these are just measurements here, so you cannot directly calculate these numbers when you see them. Okay, these are results of statistical tests which are given here, but when you look to the shape, you are right. You can say that there is no relation because they are very distributed. They are scattered. They are not close to each other. Yes, some more shapes for you. Some more figures. Yes, this is +1, -1, okay? And this is close to each other. You can see that this is 0.8 when r equals to this, okay? And this is more distributed, so 0.4. This is no relation, negative relation, and more strong negative relation. By the way, all these ones are positive one. It's possible to have a shape like this, okay, or maybe something more close to the horizontal line, and this is more close to this horizontal line, okay. You can have different shapes. They are all okay. This is not acceptable, okay, this horizontal line. But here, this is -1, this is -1, and this is 1, and so on. All of them are okay. And these are no relationship, of course, no correlation. There is no relationship between the variables in the last figures, okay? When you see such shapes, when the measurements shows you, when you put the dots, the points on the graph, and you face with such shapes, okay, they look nice, but they have no meaning in statistics, okay? No relationship. This, although they look nice. Okay, so yes, this is, what is this? Is it positive or negative? Positive, okay. Is it positive or negative?
Positive.
Good. So, is there a relationship here? No, very good. And this is a curved one, yes, curved one. It goes until here, positive, and after this point, it tends to be negative. Welcome. Yes, some more shapes. This is a positive, 0, and this is negative. Okay. These are about correlations here.